Hi everybody, I'm Christian. Welcome to Lazy Devs. Welcome to Pico-8 Hero. Welcome to our roguelike tutorial. And so today this is going to be the second episode where we're actually coding stuff. If we run our thing, we have a guy moving around. He's walking, but there are some things that I don't like about this. I want to tweak this a little bit. First of all, he's not animated. He's just like sitting there, very cramped and doing nothing. He's not interacting with the environment yet, so that's something that we also may be looking into. But also, when he walks, he's like jumps from one tile to another. That's very like old school roguelike, but that's something I want to be investing a little bit in. I want to be actually doing animations. So when you press a button, I want him to actually move from one tile and smoothly from one tile to another. The reason for that is that, again, I already talked about how we can't really show that much text in Pico-8. It's a very small screen. We don't really have the capabilities of like scrolling through a log of events, right? So we cannot like because roguelikes have like these kind of like logs where all of the events that happen are being spelled out. You encountered a grue, whatever, you encounter a dragon, the dragon spits fire at you, you get hit for that much damage and stuff like that. This kind of log, again, we can't really rely on this kind of log because we don't really have that much screen real estate. So what I want to do instead is I want to rely on animations actually to convey what is happening. So I want actually, really nice juicy animations that convey, that damage is being dealt and that you're interacting with object and stuff like that. And I feel like often when you have like these kind of like turn-based, just moving, just immediately hopping to one and to the next space, all of the enemies also hop to the next space. You don't really understand what is happening. Just like, the tiles are being shuffled around and you're like, I'm not really sure what's happening. And you have to go to the log and like read, okay, what happened in the last turn? How this world that I see now, how this relates to the one that I just saw the previous turn. Very long explanation. All right, so we're going to do an animation of this this character moving from one tile to another. That's something I'm going to be doing. Okay, so this is going to be now a bit of a let's do the animation first. So something I'm going to be doing is I want to be actually having a variable that counts the amount of frames that we've had. Just the amount of frames. So this is going to be a variable. It's going to be a very basic variable. It's going to be called t. And I'm going to start t with 0. And here in the update function, or this is going to be update function, I guess an update function. I'm just going to add 1 to t. No matter what kind of game mode we are in, I want to always add 1 to t, always count the amount of frames that have been calculated, rendered, whatsoever. You could put t also in a draw function, but that would, it probably makes no big difference. Right, and then of course we also have to think about the actual animation, right? So if you think about this, how are we going to make it so that this animation works? And we also have to think about, what kind of system, because that's not going to be the only animation that we have in our game. There's going to be lots of other animations. Maybe some of them will have more frames. Maybe some of them will have less frames. We're not really sure. I think a good idea for if you have an animation is to store that in an array. So let's do that. We're going to call this p_ani for animation, player animation. And we're going to store in subsequent frames, 240, 241, 242, 243. So what we're going to do when we animate our character, when we actually do the sprite animation, is we're going to step through this array. We're going to assign, we're going to draw the tile of the subsequent entry in each array as we continue drawing our character. I'm not sure if that was a full English sentence. I'm going to show you what I mean here. Okay, so something we can do very easily, for example, now is first of all, we can like plug in this array directly into our sprite function, right? Something like this. And then we have our guy. But now we want to actually step through this animation. So we could plug in t in here the amount of frames that we've shown. But if you see, look at this, you know, he jumps and then you're going to see some different frames, some different sprites, because now t is way bigger than 4. 4 is the amount of entries we have in our array. So this is 1, 2, 3, 4. You know, we quickly overshoot and then we don't see the animation anymore. So something we can use now is the the modulo. And I know this is complicated, but the modulo is dividing and getting the rest. Dividing and getting the rest. So, so we divide it by 4. We divide t by 4, but instead of like getting the results of the division, we're getting the rest. So whatever is not. So for example, if t equals 5, then t modulo 4 will be 1. And if t is 6, then t modulo 4 will be 2. Because 6 divided by 4 is 1, and 2. The rest is going to be 2 of that division, because 1 times 4 is 4, and 6 minus 4 is 2. It's math. It's math. But generally, modulo is a really good thing for animations because it allows us to kind of like use a big number that's like continuing counting. Something that's very easy to do, that we just did, and we can like make it loop between a certain amount of a certain series of numbers. So when you have like modulo 4, the results will always loop through 1, 2, 3, 1, 2, 3, 0, 1, 2, 3. Maybe it helps if we just step through this. Why are we getting this sequence of numbers? Why are we always getting 0, 1, 2, 4? Let's just go through this, right? So we try to divide 0 through 4, right? That's going to be 1, rest, no, that's going to be 0, rest 0. It just doesn't, it's just 0, right? Now, if t is 1 and we divide it by 4, that's going to be 0, rest 1. There is, you cannot fit 4 into 1. So it's, you know, it's 0 with the rest of 1. It's 0.25, right? Then if, and so forth. Interesting things happens when, and so we continue this like this, yeah, right, okay. So we can just continue this sequence. So, you know, 2 divided by 4 is 0, rest 2. 3 divided by 4 is 0, rest 3. Now 4 divided by 4, this is where it's interesting. It's 1, it evenly divides into 4. And the rest is 0 because it evenly divides into 4. And then we begin at 5. Now 5 divided by 4 is 1, rest 1. Because if you divide 5, you can like fit one whole 4 in 5, but then you will still have a 1 left over. And so forth. So 6 divides into 4, 1, rest 2. And if you look at this sequence, or this column, it's 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And this will continue ad infinitum. So this allows us to kind of like take a number that increases every time and constrain it into a number sequence. But this is not exactly what we're looking for. What we're looking for is actually 1, 2, 3, 4, 1, 2, 3, 4, not 0. In order to get 1, 2, 3, 4, we have to add 1 to this. So we just go plus 1 at the end. Just to show you, if you remove the 1, you will get an animation. It still works, but every now and then you get a cross. And that's, I guess I just figured out, like if you try to draw a sprite that is kind of like a crazy number that doesn't make any sense, maybe a nil, then you will always get a cross. So if we replace this with nil, you will get the cross. That kind of makes, it's kind of like a sign that something went wrong. It kind of makes sense. Okay, so with this animation, we get animation, but it's very fast. It's way too fast. We want to have something way slower, right? We don't want to have something that is that crazy fast. Well, how do we do this? We can divide t by a number. So we can divide by like 15. The problem is like when we divide it by a number, or let's divide by 2, and then that means it's like half as fast. The problem is when we divide it by 2 first and then do the modulo, we get a rest that has like a comma, I think. Let's try this. Yeah, see, it's kind of doesn't really work that well. So what we have to do now is we're gonna have to do a floor. We have to remove the part of the number behind the comma. And then we get like a smooth animation. This is a very complicated equation, but it's kind of like a typical animation that you often, difficult equation that you often do with animations. So let me step you through this one more time so we understand. So first of all, we have t, right? And t is going, we know that's going to be a number that goes 1, 2, 3, 4, 5, 6, 6, 7, and eventually, you know, it's going to be like 2048, whatever. It's going to be like a huge number, right? And it's going to go up very fast. Each frame it will advance by 1. In order to slow it down a little bit, we divide it by 15 or by 2, by a number. Then that number now grows slower. But also because we're dividing it, it's you know, sometimes it will be now, so you know, in the first frame is going to be 0, and the next frame is going to be 0.5, and the next frame is going to be 1, and the next frame is going to be 1.5. So you get like a comma number, like a not an even number, not an integer number. So in order to turn it into an integer number, we go floor t divided by 2. We divide it by 2, but we take floor. Floor means you just strip out everything behind the comma. So now we're going to get a, you know, sequence that goes like 0, 0, 1, 1, 2, 2, and so forth, right? But still, you know, it will go to very high numbers. Eventually, it's going to go all the way to 200 for, you know, very high number. And then we're going to use the modular trick. Then we're going to use the modular trick. Modulo 4, like this. So now we're going to confine the number so it doesn't get into crazy territory. Confine the number to something between 0 and 3. So it's going to be 0, 0. So the sequence is going to be 0, 0, 1, 1, 2, 2, 3, 3, 0, 0. Back to 0 again because we use the modulo. And again, now to shift it up, so we start at 1 and end at 4, we're just going to add a +1 at the end. +1. So now we're going to get a sequence of something between 1 and 4, and that is slower. We can control the speed of the sequence by dividing with a different number at the beginning. Instead of dividing by 2, we can divide by a different number. And I always talked about 15 because I figured 15 was a good number. Let's try 15. Actually, it's not a good number at all. Let's try 8. Yeah, that seems like a good number. Let's go 7.5. You can use comma numbers. I'm thinking 8 or maybe 6. Let's see what looks good. Yeah, 6 may be good. Nah, 8. It's too hectic. Okay, so that was like a lot of math for like a function that that will take care of all of our animation. I think there's like a good reason to kind of encapsulate it so we can use for different things as well. So here's where we are going to actually create a new tab, and we're going to call it tools. And this will going to be just functions that we can use, you know, for all sorts of different things. And one of them will be, you know, just get me the next frame from this array of animations, right? If you're going to have other arrays with other animations, you know, just grab me another frame that fits into this frame that we are currently showing. And so yeah, that's something we're going to do right now. We're going to call this function get frame. And yeah, it's just going to receive as an argument, it will receive an array, and it will grab one element from this array that fits, that's supposed to be shown at this current moment. So this will just like return, this is going to be just an equation. It will immediately return something. It's going to return any, and we're going to just basically copy this part here. Except there's one problem that we have to deal with. So what happens if our animation has less or more frames? How are we going to do this? Well, in this case, instead of the 4, we use the 4 here because this animation has 4 frames. If our animation has less or more frames, we can just like plug in the length of this array in here. So we're gonna go #ani, and #ani always returns the length of an array. So this way we have like a very universal function that you can use for other projects as well that will just basically animate a sprite. So you can just like now in our draw function, instead of having like this huge equation, we're going to just go get frame p ani and we're done. Ani. It's working. And the cool thing is because we are using the same function for all of the animation, they will all run at roughly the same speed. Cool. Now, something I also want to be doing is like this. You notice how we kind of like having reset the transparency and stuff like that. I want to also encapsulate this into its own function because we're going to draw other character sprites as well. We're going to have enemies and stuff like that. So let's do this as well. I'm going to call this draw SPR, draw sprite. SPR, X, Y, and then C. I'm using the underscores so we not get confused with some other. Every local variable I want to try to call underscore something, at least when it's being received as a argument. But I'm probably not going to be very stringent about this. Not going to be very consequent about this, so I'm sorry in advance. I'm just going to copy all of these because these are things that will come up every now and then where we have to reset the color and stuff like that. So why don't we just put everything into one function? We're setting the color 0, the black color, to transparent. We're setting the color 6, so this gray color. We're going to set this to yellow. Well, maybe we want characters to change colors. So instead of setting it to yellow, we're gonna set it to C, right? And then we're gonna draw the sprite. Now, instead of the ×8 here, I'm gonna this function will accept pixel coordinates because I want to animate the character moving in between the tiles. So that's why I will just take whatever pixel coordinate I receive and will just plop in the sprite in there. Okay, so let's try to use this function now in our draw game function. You will see that our draw game will become a lot cleaner because of this. We're gonna draw this. I'm gonna put it in here. And we're going to give it color 10. I can remove this. Hopefully this works. It works. So now, we just have like one function that just draws our character on the screen, and we don't have to like care exactly, about palette stuff and switching colors and everything. Everything is encapsulated in this function. So far, so good. So now we have a character. He's like moving. He's like looping through all his frames. But he is, very rigidly moving from one space to another. So as a next step, I want him to actually smoothly move between the different tiles. And that's going to be a bit tricky. Okay, so there's like different solutions to do this. I'm not sure if that's the best solution. If you have better ideas on how to pull this off, let me know. But generally, what we're having here is when we're starting a character, he has like the position of the characters is actually a tile-based position. So our character cannot actually stand between the tiles because he's always at at tile number 3, right? This is tile number 3. And in order for him to move from one, like stand between two tiles, he had to be like at tile 3.5, but that will cause a lot of headaches. So instead what we're going to do is we're going to add an offset. So we're going to call this like P-O-X. So when we move a character, we move him immediately to the next tile, but then we kind of have like an offset, like a second variable that kind of like where he's not drawn exactly at a tile, but kind of like offset a little bit. I'm going to show you what I mean with that. So here, when we're drawing the character, we're going to go px times 8 plus pox for offset x. And here times 8 plus poy, right? So now the character is being drawn normally, but now if we go p.ox equals 1, for example, you see he like moved 1 pixel, right? And we can use now this ox variable to kind of like move the character around between the sprites. This is just for animation, this is for nothing else, just animation. So for example, here when we move the character, we could of course now say like, oh, let's if we press buttons, let's just change the ox instead of oy, and now we can actually move the character, pixel precise. The only problem with that is that's more of a Zelda kind of game. That's not roguelike. We want him actually to stick to the individual tiles. That makes a lot of work that we would have to do, like collision detection, stuff like that. It makes it a lot easier if we just like stick to the individual tiles. The character cannot actually stand in between the tiles. We're gonna use this ox just for animation, so we don't actually control the ox with the keys. Instead, what we want to do is we want to actually move the position, but then there's going to be like an animation showing the character moving on its own from exactly one tile to exactly another tile. So, there's like different ways of how we could do this. Something that I kind of like, I think work very well. The draw will stay like this, just, doesn't care about what the character is actually doing. So we can keep the draw around. But something I want to do here is like, because also you don't want to actually press buttons while the animation is playing. So we're going to go like update p-walk, player walk. Or let's call this p-turn. Player turn, because it's kind of like what happens during the player's turn. So this is a new update function, it's like a new mode that we're going to put us in. Right, so in the p turn we're gonna actually make sure there's like a let's make it like this. So we're gonna go make sure that pox will actually, or like the offset variables, get reduced from whatever value they are at. We're gonna get reduced down to 0. So if we're gonna move, for example, the character to the left, then we're gonna start out making the character appear as if he is still where he started at before he moved. So we're gonna go pox equals equals 8, because we're gonna draw the character 8 pixels to the right. So if we're gonna push left, our character will actually not move now. He will start moving once you push one more time. Maybe to explain to you what I mean by that is, I'm going to draw actually a second character. That's actually where he is right now. And I'm going to give him a orange look. Or pink. Let's go orange 9. So this is the position of the character without the offset. Maybe just to explain the principle, right? So I move the character. I actually move to the next sprite. But I'm drawing the sprite 8 pixels to the right now, so it seems like I haven't moved. And the goal of our p-turn, of our animation function, is to slowly reduce this offset, so it will look as if the character is slowly moving. So something we can do is like, we're gonna go like, if p-ox is greater than 0, then p-ox minus equals 1, and then if p-ox equals 0 and p-oy equals 0, then we're going to stop animation and we're going to give the player back the control. So we're going to change the update function actually. upd equals update game. And when you press a button, we're going to go upd equals update p-turn. Okay, that's weird, but look at this. You see, we move, when we press the button, the character has actually moved. Underneath, our character is actually on the next tile. But there is like this p-turn function that makes sure that, you know, the animation, that the sprite catches up with where we're supposed to be. And I think that's like a very neat system to do this kind of animation kind of stuff. That worked very well for me. So what I'm going to do now is I'm going to actually apply it to the different directions. And you can already tell, like, there's a lot of code that goes into it. So we're going to have to figure out a good way of simplifying all of this, because we are wasting a lot of tokens on this, and there is a lot of cool ways of how we can make it more compact and more universal as well. Okay, so now I set the offsets, I think, correctly. I just want to make sure that now all of the offsets are getting reduced correctly. And already I'm starting to see like, oh, this is yeah. This is not ideal, but again, this is just like to exemplify, to give you like an early example of how this works. Okay, so this doesn't work now. Oh, I'm not sure why. I think, oh yeah, that's supposed to be OY here. Yeah, still not moving. If OX is greater than 0, then if X is smaller than 0. All right, we are not actually doing the update function, so let's do this as well. So you can see now we're moving, when you press the button, we're moving to the next sprite, and we can see that the system automatically makes our character catch up, or our sprite catch up with where we're supposed to be by reducing the offset down to 0. And when the offset is down to 0, we have control again, we can move to the next sprite. So this is basically how we're going to move our character. Complicated system. We're going to make a small break here. There's sort of still a lot of that we can do now in the next episode. So one of the things I want to do in the next episode is I want to maybe think about collision, like making sure that I actually cannot move to a spot where there is already a tile that you cannot move on. That's one thing to think about. Another thing to think about is like a small thing. I don't like how when I move to the left, he's still looking. He's like walking backwards, right? He's like walking backwards here. That looks silly. So I want actually to him to be able to look in different directions. And one final thing is I want to end is, this is a lot of code. Look at this. This is like a huge amount of tokens for, and a lot of like, we're repeating the same thing over and over again. We go left and then, you know, we go up and we change the same variables, but just a different amount. And every time you see something like this, where it's like a huge if statement and you're always doing the same things in each of the if statements, that's a moment where you can actually shorten things and make things more compact. So that's something that we're going to do. We're going to optimize this right away. So this is not. I think it makes sense to optimize it right away. And there's like, I think, some good techniques that we can test right away here that I think is going to be some very useful. I'm going to remove this shadow underneath so we can see that, you know, now we can actually see how this looks like. He's a bit slow, I have to say, so we might be interested maybe to add a function that we can like change the speed of how fast he's moving. And what else? Oh yeah, so I want to also maybe make a thing where I can make different animations happen, because right now there's basically just one animation. I move and he catches up with my position. But if I move against the wall, that's going to be like a different situation where I'm not actually moving to a different tile. I want him maybe to bump a little bit against the wall, you know, like move a little bit into the sprite, but then recoil and return back to where he was. And that's kind of like a different situation. We have to like we're going to use the offset, but we're going to use the offset differently. Instead of reducing it from a number down to 0, we're going to make it go up and then down again, so he can like bumps against the wall. But that's something that's going to be for the future. If you have any questions, let me know in the comment section. might have been a bit of a complicated situation. Generally, I'm like feeling very bad because I'm explaining very complicated stuff here, and I used to like these very basic kind of things. I'm worried that you guys might not be catching up. So let me know in the comment section. And as always, the code for today's episode is going to be down in the doobly-doo. See you next time around, guys. Bye bye.